Hello, curious minds. What if I told you that one man with his brilliant mind and a simple telescope completely changed our understanding of the universe? Get ready to have your mind blown and your understanding of science expanded. Because today we're diving deep into the incredible life of Galileo Galilei, a true visionary who dared to challenge the cosmos. Introduction. Today we're going to explore the life and groundbreaking contributions of Galileo Galilei. He was not just a scientist, he was a revolutionary thinker who laid the foundation for modern science. His story is filled with discovery, controversy, and an unyielding quest for truth. You're about to embark on a journey that will show you how one individual's curiosity can reshape the entire world. This isn't just history, it's the thrilling narrative of how we started to truly see our place in the vast universe. Body. Galileo Galilei's journey began in Pisa, Italy in 1564. Born just a few years before William Shakespeare, Galileo grew up in a time of great intellectual ferment. His father, Vincenzo Galilei, was a renowned musician, which perhaps instilled in young Galileo a deep appreciation for patterns and rigorous observation. From an early age, Galileo showed an extraordinary talent for mathematics and a keen interest in how things worked. In 1581, at 17, Galileo enrolled at the University of Pisa to study medicine. However, he soon found himself drawn to mathematics and natural philosophy. It was here that his lifelong passion for observation and experimentation began to take root. He realized that the world could be understood not just through ancient texts, but through direct observation and measurement. One of his earliest and most famous discoveries involved the pendulum. Legend has it that he observed a swinging lamp in the Cathedral of Pisa and noticed that its oscillations took the same amount of time, regardless of the swing's amplitude. This observation, made around 1583, led to his formulation of the law of the pendulum, crucial for the development of accurate clocks. After leaving the University of Pisa, Galileo pursued a career as a lecturer. In 1589, he became a professor of math at the University of Pisa. During this period, he conducted experiments on falling objects, challenging the long-held Aristotelian belief that heavier objects fall faster than lighter ones. While the famous experiment from the Leaning Tower of Pisa might be apocryphal, his extensive work demonstrated that objects fall at the same rate, regardless of their mass, assuming negligible air resistance. This was a radical departure from established thought and a significant step towards modern physics. In 1592, Galileo moved to the University of Padua, where he spent 18 productive years. He taught geometry, mechanics, and astronomy, and invented numerous useful devices, including an improved military compass and a thermometer. His lectures were popular, and his reputation as an innovative thinker grew. However, it was in 1609 that Galileo made a discovery that would forever change his life and the course of astronomy. He heard about a new invention from the Netherlands telescope. While he didn't invent the telescope, he quickly understood its potential and set about improving its design. Within months, he constructed a telescope that magnified objects up to 20 times, far superior to anything available at the time. With his improved telescope, Galileo turned his gaze to the night sky. In 1610, he published his observations in Sidereus Nuncius, or Starry Messenger. This book contained revolutionary discoveries. He observed that the moon was not a perfect, smooth sphere, but had mountains and valleys, much like Earth. This challenged the Aristotelian view of celestial bodies as perfect and unchanging. He discovered 4 large moons orbiting Jupiter, which he named the Medicean stars. The existence of celestial bodies orbiting another planet, not Earth, directly contradicted the geocentric model, which placed Earth at the center of the universe. He observed countless new stars invisible to the naked eye, suggesting a much larger universe than previously imagined. He also observed the phases of Venus, Just like the moon, Venus showed a full range of phases from crescent to full. This observation was critically important because it could only be explained by Venus, orbiting the Sun, not Earth. In the geocentric model, Venus would only show crescent and new phases. These observations provided strong empirical evidence, supporting the Copernican heliocentric model, which proposed that the Earth and other planets revolved around the Sun. This model, originally put forward by Nicolaus Copernicus, had lacked definitive observational proof until Galileo's telescopic discoveries. Galileo's support for the heliocentric model put him on a collision course with the powerful Roman Catholic Church, which adhered to the geocentric view, largely based on interpretations of Scripture and Aristotelian philosophy. In 1616, the Church declared the heliocentric theory to be foolish and absurd in philosophy and formally heretical. Galileo was warned not to defend the Copernican doctrine. He largely complied for several years. However, in 1632, Galileo published his masterpiece, Dialogue Concerning the Two Chief World Systems. This book presented a debate between three characters: Salviati, a Copernican advocate; Sagredo, an intelligent layman; and Simplicio, a defender of the Aristotelian Ptolemaic view. Although Galileo claimed the book was an impartial examination, it clearly favored the heliocentric model, and Simplicio was often portrayed as naive. This publication caused a massive stir. The Church perceived it as direct defiance of the 1616 injunction. In 1633, Galileo was summoned to Rome and tried by the Inquisition. He was found vehemently suspect of heresy. He was forced to recant his views and spent the remainder of his life under house arrest at his villa in Arcetri, near Florence. Even under house arrest, Galileo continued his scientific work. He completed Two New Sciences in 1638, a book that laid the foundation for modern physics, particularly in kinematics and the strength of materials. This work, considered by many to be his greatest contribution, provided the mathematical framework for understanding motion and laid the groundwork for Isaac Newton's laws of motion. Galileo Galilei died in 1642. His legacy, however, lived on. He is often called the father of observational astronomy, the father of modern physics, and even the father of the scientific method. His insistence on observation, experimentation, and mathematical analysis transformed natural philosophy into modern science. Conclusion. So what have we learned about Galileo Galilei? We've seen how his insatiable curiosity and brilliant mind led him to question long-held beliefs, even at great personal cost. From observing a swinging lamp to perfecting the telescope and revealing the true nature of celestial bodies, Galileo's journey was one of relentless discovery. His story is a powerful reminder that challenging the status quo, even when faced with immense opposition, can pave the way for profound progress. He taught us to look, to question, and to trust our observations. And that, my friends, is a lesson that continues to inspire scientists and thinkers to this very day.